what I find interesting is that you start out with these almost ghost-like objects that you can't measure the extent of, you can't physically access. It's a probability. So how do you wrap your head around that? It is these sort of ghostly objects that move through each other without a physical extent. But what I find fascinating is when you have them collectively come together they do form a physically measurable entity, the macroscopic wave function that collectively they organize into. Now you can touch it, you can feel it, and it has macroscopic consequences. And for me, that's one of like the incredible things about, just the shape shifting nature of things at the quantum level not having a more ethereal quantity, but equally they're the same things that come together to form what we can touch and feel. All of these have at the heart of them, it is a self-assembly of these electrons, which started out in the shape-shifting form, but they come together, and also they can shape-shift to form different things. Under certain conditions, you could have the electrons come together to form a magnet. Under slightly different conditions, they would come together to form a superconductor or an insulator. And I think, to me, that's what's incredible about it. It's not the stuff that makes it up, it's how they interact with each other. And that's what I find really fascinating. This idea of emergence, of collectivity, is not I think we often think of reducing things down to there's some constituent particle that's at the heart of everything. And I view it very differently as, it's interesting to study the constituent particle, but what I find fascinating is how do we understand the material universe, trees, rocks, nature, buildings, and all of them are from these ethereal particles, which are a probabilistic wave function, but coming together, interacting with each other, they form all of matter that's all around us. Yeah, one of the things I wonder is why are we trying to develop a theory of everything? And is that a meaningful quest even to progress towards a theory of everything? I am not convinced it is. I think the idea of a theory of everything, the basis is we're working towards some model which we can put everything, all these forces into it, and somehow we come out with an equation where we can explain everything in the universe. And I think for a theory to work, it would need to be predictable. So we would need to be able to predict everything in the universe. I think that's one way of looking at it. But I think that a model-based system is actually not going to be able to explain everything in the universe. And so I think one question is, okay, if we do believe in a theory of everything, how would we go about testing it or finding what that theory is? And another question is, well, firstly, do we believe such a theory of everything even exists? And not just how do we go about, not just assuming such a theory exists and then going about testing it or finding it. And I don't think there's evidence that a theory of everything exists. And one of the reasons I say that is emergent forms of matter. So if we were just electrons, so we have not even put in gravity, we haven't even put in anything else, just with electrons, we can start with, say, Schrodinger's equation, we can write it down, we're not in any doubt about what the equation is. We put every single electron into this equation, every single electron interacts with every single other electron. We know what the forces are. And one has atoms, the electrons interact with the ions, one has, many, many terms in this equation. But even if we were able to solve this equation, which would be a challenge, but let's say we had a supercomputer and we could solve this equation, would it tell us what matter is, what emergent? I don't think there's any evidence it would, because I think a lot of evidence is to the contrary, that the properties which emerge at a large scale, matter which we observe, macroscopic matter, actually the quantum phases we observe are dramatically different. So like I was telling you about consciousness and neurons, it's like saying, let's aim to achieve a theory of neurons and how they interact with chemicals, and let's spend all our resources trying to find a perfect theory. That's nice. Will it tell you about consciousness? I don't think it will. And it's like that when we say, let's spend all these resources trying to find a theory of everything. Is it going to tell you about emergent phenomena, which are dramatically different from these particles interacting with each other? I don't think there's any evidence to show us, actually, there's evidence to the contrary. Those emergent phenomena will not be yielded by this theory where we put in all the fundamental reduced particles we found and the forces between them. So that's my two bits
I guess
on a theory of everything.
I'm just sort of going back to the original thing I was saying about curiosity about the universe and our place in it and like why everything is the way it is. I've just got this question: is like, there has to be some machinery that makes everything work. Right, and that, and
I'm
so
not sure. I'm not sure.
you're not sure. Okay,
No,
well, maybe
no.
not. Maybe that's like a naive point of view. But it really feels like if we drill down further and further and further, like what's the cogs? What are the cogs turning to make things consistent and happen? Because I don't know. Maybe it's so abstract that I start losing the plot.
I think, I don't believe in this mechanistic view where we put the bits, it's like a Lego. We put the bits together and we
So
build.
what is it then?
I think that it is about an infinity of unknown. When you put these things together, we need to recognize it's not a closed mechanistic system. There's always portals to the unknown that we're not going to close up. That is the wonder of being in the universe, the unknown. There's always going to be the unknown. That doesn't mean we shouldn't go out and look because everything's unknown. It means the wonder isn't looking, knowing what you're going to find is never what you model. It's always beyond that.
So what about if we could make some intelligence that's more intelligence than us, that can handle more abstract concepts than us? Do you think it could then start and say, let's just be fantastical. Say you could build that collider that's the size of the solar system,
Sure.
smash things together. So we could start actually more easily probing avenues that are out of our reach right now. What would we find, do you think?
I mean, I think we would find new phenomena.
Right.
I absolutely think we would.
But it would go on forever. There's more and more stuff.
Absolutely, yeah.
So quantum gravity, there'd have some problems with quantum gravity even there, and there'd be something beyond that.
Exactly, yeah. That's what I think.
So just
I
rabbit
think you're
holes
never
keep
going to
going,
close it and be like, okay, we found a way to fit both of these into the equation. We're done. No, I think that the more you look, the more there will be new phenomena.
Makes me want to still go down that rabbit hole and find out what those things are.
Oh, yeah,
I
absolutely. No, I don't think that means we shouldn't look because it's unknown. I think that's why we look, but it's less looking to create a closed model. It's more looking, knowing it's just always going to be beyond whatever we... So I think a model is like a cartoon that we draw of what we think we know, but we're always going to go beyond that.